So then what is the method of writing these numbers in scientific notation? If I have a number in scientific notation, I want to write it in my regular form, or if I want to go from the regular or standard form to scientific notation, what is the way that what is the method to do that? And it's really, really simple. If I give you a number, something like 146, you know, like you always know that there's an invisible 1 multiplying here and an invisible 1 dividing here. Well, there's an invisible 10 to the 0 always sitting by every number, because this is just a 1, right? Anything to the 0th power is 1. And so basically, if I wanted to convert this number to scientific notation, the rules are that obviously it takes a form like this, but the decimal must be after the first digit. That's where I want the decimal to be. Now, you know, we can't just put decimals in there. That just changes the number. So the only way I can make this decimal bounce over to the left is by dividing this by 100 or by 10 to the 2. So I'm going to divide this by 10 to the 2. I need to multiply this, which was 0, by 10 to the 2. So that way I'm not doing anything. If you look, I'm just multiplying by this over this, which is just a 1, and multiplying by 1 doesn't change anything. And so that becomes 1.46, and that becomes 10 to the 2. Simple. Another way of just looking at it is that if you are going to make this smaller, you got to make that guy bigger. If you're going to make this bigger, you got to make that guy smaller. Let's look at some more examples. Let's put 2.94 times 10 to the 12. Well, no, let me not do that now. Let me just go ahead and give you, look at and change another number to scientific notation. So let's say if I have 646, 0, 0, 0, 0, 0. I want to write this in scientific notation. You know my decimal is already here. I need to make it bounce 1, 2, 3, 4, 5, 6, 7. The only way I'm going to make it bounce into the 7 is by dividing this whole number by 10 to the 7, which means I have to multiply it by 10 to the 7 so that I can make up for it. And so now I have 6.46 times 10 to the 7. That's all there is to it. You know, if I'm going to bounce this to the left, meaning making it smaller, don't think left and right, because kids keep forgetting a few months later, do I move left, do I move right? So think about it in terms of smaller and larger. So if I make this smaller, I have to make this bigger by the same amount. And you can do it right away that way. So let's try another one. If I gave you 96200000000, the decimal is here. We need to bring it there. 1, 2, 3, 4, 5, 6, 7, 8, 9. That becomes 9.62 times 10 to the 9. Small quantities, just as easy. Let's see if I have 0.00000000062. Now the decimal is here. We need to have it after the first digit. Means I got to make it go 1, 2, 3, 4, 5, 6, 7, 8, 9. I got to make it bigger by 9. So it becomes 6.2 times 10 to the negative 9. So if I make this bigger by 9, I need to make this smaller by 9. That's where that comes in. And so I have 6.2 times 10 to the negative 9. And really that's all there's to it. Another thing to kind of recall is usually these number of zeros is just one less than the number up here. So 1, 2, 3, 4, 5, 6, 7, 8 zeros will usually give you that. For the negatives, it's a little thing to remember, a little kind of shortcut that you know, if I have so many trillion zeros before the 6, or leading zeros I should say, then I'm going to have one less in terms of the number up here, because it takes one to just get it over to the right side from there to there. So I hope that helps you understand how to write small or large numbers in scientific notation. I'll do one more, 0.000000913. And again, I need to bring the decimal here. That's 1, 2, 3, 4, 5, 6. So that would be 9.13 times 10 to the negative 6. Again, notice that's 6 and that's 5 zeros there. So it's just a way to keep things in mind. I hope this helps.